Hey everyone, welcome to the 308th episode of the Internet of Things podcast. This is your host, Stacey Higginbotham, and your co-host,
Kevin Toffel.
And we have a really great show for you today. We're going to be talking about Chipageddon, Ring, and the LAPD. Amazon has a new crowdfunding-esque type thing. Wise has new color bulbs, and Facebook has a smartwatch. We're also going to be talking about a peer-to-peer communications network for, well, people and the Internet of Things called OWL. And the protocol they use is the cluster duck protocol. So,
Quack.
Fun with puns. All right. We're also going to give you a little tip for your Google Assistant and talk about some funding, an acquisition, and DIY smart home image recognition. So, all of this plus our guest this week is Alistair Allen, who is head of technical documentation at Raspberry Pi Trading, which is the business side of the Raspberry Pi Foundation. He's going to be talking to us about the chip, the specially designed chip that is in the Raspberry Pi Pico. We're going to be talking about why the Pi Foundation did that and what it's good for, including a little bit about TinyML. All of this will be brought to you by Very. So let's get started and hear from our sponsor this week. This week's sponsor, as I mentioned, is Very. So are you looking for an IoT development firm that has been there and done that? Very's award-winning team of senior engineers, designers, and data scientists will work with you to get your biggest IoT hardware and software projects fully operational. You can learn more at verypossible.com. That's www.verypossible.com. And you'll hear more from them later on in the show. So now, let's talk about chips. Whoop, whoop, but not that kind of chip. Oh,
not
we all get
Project
so
Chip.
excited. No Project Chip. Update on that? No update.
Zippo.
Very sad. Okay, but let's talk about silicon. What's been happening is we haven't talked about it in depth. I think we've mentioned it on the automotive side, but basically, the pandemic has caused some demand fluctuation in the silicon market. I should say the pandemic plus the increasing need for silicon in all parts of life have caused some weird demand fluctuations in chips. And what's happened is the manufacturing companies have changed around their product lines. So when the automotive guys said, hey, we're not going to build cars for a while because no one's buying cars, they were like, all right, we'll use that capacity for a different type of chip. And now the automotive guys are like, oh, wait, no, we want more chips now. We're ready. And
that's too bad.
Yeah, TSMC and other companies who manufacture chips are like, well, we can't retool our line for you, and we've got all these other demands. So just wait a minute.
They're all making GPU chips right now, trust me.
Yeah, GPU. They're mining Bitcoin. They're making GPUs for like machine learning. There's high-end chips for phones. I mean, we're putting chips in a lot of places. So that's part of it. Also, things like wacky weather situations. So Samsung actually shut down their semiconductor plant in Texas and Austin. I have been there, y'all. It is large. It is a 300 millimeter fab, and they had to take it offline for a couple of days because there's no power there. And that's great from a, please, yes, don't use power. We could use it to keep people warm perspective, but it's also really bad for what's happening in the overarching chip market. So we're actually going to have a guest next week, I believe, talking about what this means. But broadly, it means for the lack of sometimes it's even like $20 or $30, these components, you can't produce a car or a smart thermostat. The companies with the biggest orders, so big companies like they make high margin chips like Apple, Qualcomm, they're doing just fine. They're getting their orders in just fine. It's kind of the companies on the lower end. Well, and I don't want to even say lower end because these are just not smartphone chips. We'll call it that.
Let me ask you, I think you know this off the top of your head, given your background of covering the chip sector. I just think this puts a finer point on it as well. A lot of people don't realize Apple doesn't make its chips.
Most chip companies don't make their own chips.
Right. The chip fabricators are not always the chip designers, for example. Like Samsung can make its own chips. It can design and fabricate them. a lot of companies will go to, say, TSMC or Global Foundries and say, here's our design, make the chip for us. Are there any IoT chip fabricators, any chip designers that are also fabricators? Like Broadcom, I don't think so.
No, so Intel, Samsung, AMD did their partnership with Global Foundries. What happened is all the way back in this was a trend between 2000 and 2008, 2007 maybe. What happened is building a chip plant got more and more expensive because the technology involved became more and more, it became fancier. So what happened is one single company couldn't make their own chips. Like when Intel launched, Intel actually did everything. They made their own chips. They made their own chip making equipment. And eventually they spun out the chip making equipment and just decided to make their own chips. But most companies, and even like Qualcomm, when they launched, it was a big deal that they were quote unquote fabless. They didn't own their own fabrication plant.
Right. Because a chip fab can cost billions of dollars.
So many billions. I mean, it is a ridiculously high number. Plus, when you invest that much, you need to keep your chip manufacturing facility running 24/7, which means you need to have a lot of demand for those chips, right? And up until Intel has that demand, Samsung has that demand, maybe today Apple has that demand, but it's very hard you're producing X number of wafers, and on a 300 millimeter wafer, there are, actually, I don't know if it's thousands of chips or not. There are a lot of chips.
It can be a lot of chips.
Yeah,
but we're talking typically, I would think, less than 1,000 for a very small die of smartphone chip. Maybe you have 500. These are estimates. Bigger Intel chip, maybe you have, 200.
I don't know. I truly don't know. Like on a 300 millimeter wafer, how many chips, and it depends on what process node you're running it at.
Right.
But yeah, the point is you can make a lot of chips in 24 hours, right? On a production line. And so what happened is TSMC, AMD kind of teamed up with IBM. They created Global Foundries. There's an SMT. There's a couple, but there's not that many.
Taiwan-based, I think, SMT Micro or something.
Yeah. There's a bunch of companies that are these fabrication plants, but there's not enough for right now. And the other nuance here is not every chip is made at the highest level. Like on a 300 millimeter wafer, there's not as many going 11 nanometers. So at the most advanced levels, there's tons of chips that need to be made. Like the sensors for automotive are a great example of this. They can be made on a 200 millimeter wafer and at a very large process node. But a lot of companies haven't optimized for that because those aren't really highly profitable. And that's the other element we're seeing here is if you're not a fancy computer chip.
If you're not like an Apple that needs hundreds of millions of the chip each year, and you're going to put out an IoT product that you're going to go with a $50,000 chip order to kind of get in the market, you're at the back of the line.
Yeah. And we haven't even talked about the fact that there's also all the big companies like Apple, Google, Amazon, Microsoft. They're all designing and calling in orders for their own chip designs too, which is different. So there's a lot happening here. The bottom line is there's no great solution for the short term. And so we're going to still continue to see shortages of goods on the hardware side, on cars, things that require silicon that's low end. And I don't know if we'll see reactivation of some of the fabrication plants. I mean, when I moved to Austin in 2001, the big story was Austin had a bunch of fabs and they were all shutting down because they were old. And I don't think that they're going to bring any of those back, especially not in Austin. But we'll see how they solve this problem. But it's going to be a very long-term problem.
Mm-hmm.
So, okay, that was a lot about chips. Once again, we get me talking about chips and look what happens. Let's talk about Ring and the police. The biggest story on this front is the Electronic Frontier Foundation has found that the Los Angeles Police Department requested Ring footage of Black Lives Matter protest. And this matters because this is the first time that there has been documentation that a police department has specifically asked for Ring footage for Black Lives Matter's protests. And this is in addition to, all the government surveillance that is out there, or the kind of the cameras that are in commercial areas and requesting that data. So there's a couple things here. I've already said that I hate the fact that Ring uses police departments to market their products. I think that's a problem. Mm-hmm. A lot of people look at this and they're like, hey, Ring should limit what the LAPD can do with the data that they gather. I don't think that's a reasonable thing to do. I think Ring needs to make it very clear to their customers that they can refuse law enforcement requests for information. And I also think that when law enforcement tries to get this information, they should have a warrant. Like, I think Ring should make it much more difficult than it is already. I also think once the police departments have this data, I think they should be required to dump it after the case. And I know if they go to court, that's kind of a long term, so it could be a long time, but I don't think they should be able to just go through the neighborhood and request large swaths of data easily.
Maybe, I agree. Maybe the courts can work out some way to hold it in escrow in case there's appeals, et cetera, for a certain amount of time.
Oh, that's interesting. I just don't like the idea of home devices becoming part of a surveillance network. And I don't think people who buy this stuff want this either, but they're not thinking about that as a big picture. And I don't think they should have to.
I agree with everything you said. I would take it a step further, and maybe I'm overstepping here, but if I don't have a Ring camera and yet I walk past a Ring camera, I have no way to give or not give consent. And that's a whole nother aspect of this.
Oh, yeah. No, we haven't even talked about that fact. I mean, the argument is, hey, you're on a public street, people can do what they want. But in this era of easily searchable and forever online data, I think we need to revisit those conversations.
Yes. It's to the point now where when I'm out in public, I assume basically that I could be being captured on video or audio, et cetera, somewhere, whether it's a store, a street, a neighborhood. I don't change my behavior because it's not like I'm going out there and smashing people's mailboxes or anything like that. But
I don't pick my nose on the street anymore.
There's a habitual change. That's good. It's to the point now, and this is sad, but I assume that I am, in a sense, surveilled.
Yeah, and that's not where we want to be as a people, but that is where we are getting to rapidly.
Well, I should say, though, that you're right, not where we want to be as a people, but I realize that we have a U.S.-centric view on this. And, having been over to London and all, there's cameras everywhere, and that's just a fact of life these days there. So we're behind the times there, and we're pushing back, but I realize it's different in different locations and regions around the world.
Yes. All right. So we'll talk more about this, I'm sure. I would love to see some legislation start getting pushed through about this, and we'll see. Okay. Let's talk about Amazon, which, by the way, owns Ring. But Amazon has a new
Kickstarter.
Yeah, basically. They're calling it Build It with Amazon. And the idea here is they're going to let people vote on what products Amazon should build next. And the first, options up are a smart scale for $35 or $34.99, a smart cuckoo clock that is Madam A enabled for $79.99, and a smart sticky note printer, which is available for pre-order for $89.99. And Sheesh. Surprisingly, the sticky note printer is the most popular one. And I'm guessing it's the idea here is you give yourself a voice note and it prints those out for you.
Right. Well, so you can, in one of the examples, they are showing a to-do list. So if you have a to-do list that you manage with Madam A, it's got multiple items on there. You can ask Madam A to print that to-do list for $90. It's actually $115 after the pre-order goal is met, if it's met, that is.
Yeah. So I don't know.
That's why I said Kickstarter, because it very much feels like that. On one hand, personally, I think 2 of the 3 products are just silly. I mean, the cuckoo clock, don't need that connected. And I don't print sticky notes, nor do I want any more paper in my life. The nutrition scale is interesting, but I don't find it terribly smart when I think about how it works. So an example might be, the example they use is, put a bowl of blackberries or blueberries on the scale, and it will weigh the blueberries. Okay, that's Nice. And then you can ask Madam A how many calories or how much sugar are in these blueberries. This amount.
The interesting thing to me is you can tell Madam A what's in your bowl or whatever's on the scale. So you say, how many calories are in this many blueberries or in this amount of blueberries? And it will tell you what would be, and then you can ask for nutrition information, or you can see it if you have it hooked up to a smart display. So I actually think this is, of all the products, I would do this partially because I do like bread baking and stuff like that. And it might be cool if you could link this to recipe stuff. That's not happening in the initial build. But this feels like a good product that could be part of an ecosystem of devices where having a voice and a cloud connection makes sense.
I don't find it very technically impressive, but it's a clever implementation to figure out how much something weighs on the scale. And then Madam A is told what it is. And then all it does is go out to the cloud and get the calculation and return it. I mean, it's actually a very simple from a technical standpoint, but from a practical standpoint, yes, I could see a lot of people jump on this. And surprisingly, not many have compared to the sticky note printer.
Okay, so that's what this is. Interestingly, all of these devices are dumb without an Amazon Echo. So these will link to your Echo. It looks like they have to be close by, so maybe they're only Bluetooth based. It's unclear. So that's a little, I don't know, interesting, weird, notable.
Yeah, I think what's even more interesting is it's a change in how Amazon is looking at its day one product line. Before this came out, they would just make something like the Echo frames and say, here you go, buy it early if you'd like. Now and maybe it gets back to some of what we just talked about with chips and the supply and demand. Now it's, hey, we might make this if enough people want it. And I think that's very smart rather than incurring the investment in a product that isn't going to sell.
And this is actually how companies like GE, for example, GE Appliances has used Kickstarter this way. A couple other companies have used Kickstarter this way. And it's like, hey, if this product meets its goal, we will make it. Otherwise, no. So it's kind of like product research. So yeah, now why Amazon decided it needed to do that on its own? Well, because it's Amazon.
And why they decided on a cuckoo clock, I don't know.
Well, the other thing to think about is Amazon usually builds these things for themselves, but they think about them as services for everyone. So if I were Kickstarter, I would be a little concerned because my hunch is Amazon will offer this, especially for others building Echo-related devices. It makes a lot of sense. If I'm like, I have a brilliant idea for a new Echo, a little Madam A style light bulb, or I don't have a brilliant idea, y'all.
Yeah, they could even help projects manage the supply chain and the production because they're already doing that for their own products. Kickstarter projects, the Kickstarter people have to go and work with their own providers of the hardware and the production, typically in China, and do all that, and the e-commerce aspect as well. So
yes, so lots of fun there. Very interesting. Speaking of fun, let's talk about colored bulbs.
Fun.
Wise has a new colored bulb set. They had the white tunable bulbs. Now they have a 4-pack of color bulbs for $34.99. It is shipping in March of this year.
Maybe.
Yeah. Speaking of
Kevin's bitter because the Wise band is not here yet.
Yeah, Chipageddon strikes again. Wise actually sent a note out a couple weeks back to his users saying, hey, we're going to focus less on some IoT products because we're having some supply chain issues. This, though, is connected. You can have voice control. You have lots of colors. It's really cheap. When we get these bulbs, we will totally tell you what we think.
Yeah, they're brighter than typical color bulbs that we might have seen on the market prior because they go up to 1100 lumens, which is nice. I'm curious if that's specifically for the white or all colors, because typically color bulbs are not as bright in the color bands.
That is true. All right, so yay. Kevin, you'll be picking up a pack. I'll probably pick up a pack. So fun. Okay, now, will you pick up the new rumored Facebook smartwatch for health?
I can't believe you're even asking and expecting any kind of answer other than no.
You might have had a heck no.
I'm trying to be nice today.
So what's the rumor?
The rumor is that Facebook is actually working on its own smartwatch that would arrive next year, assuming chips are not a problem anymore. It would focus on messaging, which that makes total sense. I'm not a Facebook Messenger user, but if I was, that would make sense to me. but also offer health and fitness features. And my take is I don't particularly want them to have that kind of data. So that's why I say, no thanks, I'll pass.
Let's talk about a really cool project that may not ever go anywhere, but because I am so obsessed with mesh networks and peer-to-peer mesh networks, we're going to talk about it. This is what is this? This is the launch of something called Project OWL. And Project OWL stands for
Organization, Whereabouts, and Logistics.
Yes. And the idea here is to build a mesh network to work between phones and devices when there is no available internet. So the devices talk to each other using Bluetooth. Maybe one day they'll use LoRa. And right now, Project OWL is mostly focused in Puerto Rico, where they've got 30 solar-powered wireless duck link devices. So now let's get into the protocol that the OWL network runs on. And that protocol is called the Cluster Duck Protocol.
Of course it is.
I do like this. So the idea that, I don't know if y'all are familiar, there was a project way back in 2009 or so called Serval. You loaded the code on your phone and it turned any nearby phones that also had Serval. You could talk to each other using your Bluetooth, basically, from the phone. Mm-hmm. It was lovely. ClusterDuck is like that. It's got its own communication protocol where devices that are close enough to each other can talk to each other and then piggyback or send their data over like a wireless connection to the internet if there's one available. So the idea here is you get like GPS information, maybe some sensor readings. Their focus has been on disaster recovery and public safety, but they also have projects tied to things like industrial IoT. So like you could monitor everything on your remote location oil rig platform and send it to computers on the site to deal with, and then send that data up later via satellite if you want.
Yeah, it's just small amounts of data. It's not like you're not going to send video from a camera in an industrial production facility, for example. It's short, limited amounts of bits, which actually is perfect for IoT devices.
Yeah. And location and text that say, yes, I'm alive, despite the fact that, I have no power or internet. So,
oh, I just noticed something in the spec.
What?
We looked at it before the show, but I didn't see this. I'm looking at the actual message format, and the first 64 bits are a hex value that identifies the device in the mesh network. That's okay. You have to have some kind of device ID. But following that, it says compatible with LoRa Dev EUI format. Interesting.
So you could use this with the LoRa network, which means you can go longer range.
And interesting.
The ClusterDuck people have sensors that you can purchase that have the protocol already on them, the sensors. They've got the duck sensor, the detector duck sensor.
Super duck.
Yeah, lots of different ducks and then ways to optimize. The duck is kind of fun. It floats in the water, and you can also attach them to drones. And then you've got like protocols to manage like all the sensors. It's a very fun thing. So play with this if it's your jam, or just look at it. I thought it was fun. You know me, I love.
There's even code available. It's an open source project. There's even code available on GitHub that you could install to an Arduino or some other device and then use their protocol to communicate to other devices. So if you feel like testing duck messaging, you could do it.
Yay. All right. I have a fun tip for people.
Oh boy.
Enjoy. Okay, everybody, this may set off your assistant device, your Google Assistant device. So I'm about to trigger this because I don't know how else to do this story. But I was on Reddit because why not? And the Google Home Reddit had a little thing and it worked for me. So they said, hey, instead of saying, hey, G, but say the whole word, say, hey, poodle. And I went around trying it and my husband was like, what the heck are you doing? But it works. If I say, hey, poodle, what's the weather? My Google Assistant will respond to me and tell me the weather.
As did most everybody else's just now, I'm sure.
Sorry.
No, actually, I'd be curious how many it works on and how many it doesn't, because I tested it before the show and it wasn't working until I tried it the way you did. We just blurted it out with a command.
Yeah, I feel like there's a definite way I say, hey, G, right? And I can't say, hey, poodle that way, I guess. I say it more like a normal person. Anyway, okay. Moving right along, we've got some news bits. Kevin?
Yeah, here's a quick news bit on funding from Recogni, which is an AI startup. They create AI-powered vision recognition modules for cars. They have raised recently $48.9 million. I don't know how this applies with the whole chip shortage and what that's doing for them, but they may focus on just the software part of it. I don't know. But they do have an integrated module. Oh, well, there you go. They have an integrated module with cooled image sensors, an external depth sensor, custom inferencing chip, and it only consumes about 8 watts of power.
That's kind of a lot of power.
On a car.
But, not on a car. You're right. I was like, 8 watts is a lot. But yes, not on a car with the giant battery. All right. Or no, lots of giant batteries if it's electric.
Yeah.
Okay. Other news. Verizon, the U.S. telecom carrier, they have signed a deal to acquire an Austrian industrial robotics software company called Incubed IT. And this was kind of an interesting deal because Verizon is buying a company that provides software for industrial automation robots. And it's doing this because it's trying to create a package of solutions around the 5G factory. Usually telcos do not get this far down this, or I guess it's up the stack, really. They're worried about providing the communication. But with this deal, Verizon's actually going all the way up the stack to the application itself, which is pretty unique and points to like a more aggressive systems integration role for Verizon, maybe in factory automation.
I'm going to take a wild guess on why they're doing this because it is unique, and you can tell me if I'm out of bounds on this one. The 5G rollout, at least for millimeter wave in the US, has been very staggered, very slow. Not many people have phones that can use that super, super fast 5G service. But if Verizon wants to put in some millimeter wave dishes and all the other equipment in factories, boy, oh boy, that would help it take off.
Well, so there is a big movement for private networks in factories. So that's a thing that is happening. And this, yes, gives anybody who's establishing a private network a possible reason to choose Verizon for that, I guess, because if you care about this type of, I don't know. It also will help Verizon, I will say, understand better the use case and the network design requirements. So that could be a reason also. But yeah, I thought this was a really interesting deal. So I wanted to highlight it for people. If you have more insights on this, feel free to give me a call. Send me an email. All right. And now let's talk about a fun DIY thing the technically savvy or the people who want to become technically savvy can do. Kevin wrote about DIY smart home image recognition. Kevin, what did you discover?
Well, I haven't actually done any of these projects yet. However, there have been a large number of blogs, projects, videos highlighting how you can do it yourself with a Raspberry Pi and a camera, basically have object, image, or person recognition. I took it a step further that you could apply to your smart home. You could use it for anything, obviously, but from a smart home perspective, I think it's pretty interesting because a lot of the image recognition and person detection type features that are offered in the smart home, they may be part of a subscription that you don't want to pay. They may go up to the cloud. In fact, they typically do. And that gets your information, your video feeds out of your control. By doing it yourself with a Raspberry Pi, a camera, and certain software, and spending some time training using machine learning, training the model, you could theoretically do it yourself. There's just been a number of these, a couple of video demonstrations. Even the ARM folks had a video out just last week or the week before showing a Raspberry Pico chip that when it detects motion, fires up an actual Raspberry Pi, which has more compute power. That has a camera, and the camera then says, oh, somebody is here, and it sends a notification to a phone. I mean, it's not as, say, glitzy and polished as a store-bought type solution, but there are benefits to it. There's even a lot of hooks into things such as Home Assistant and so on. There is a whole challenge, though, and that is once you can set up a Raspberry Pi in your house to detect things that you want to detect, what do you do with it? So I shared a little bit of information, not in depth, about MQTT as the messaging system you could use, which again, you can run that on a Pi. There's an open source project called Frigate that works with Home Assistant that you could integrate these recognized people and such into your smart home and trigger events. So this is not like go out, do it, and it's a piece of cake. It's going to take some tinkering. But it's interesting to me how cheap it is if you have the know-how.
Yes, and as go DIY, eventually products will follow. So, yay. Okay, that concludes the news portion of the show. Now it is time for the Internet of Things podcast hotline. This is where we answer your questions about the IoT. And the Internet of Things podcast hotline is brought to you by Infineon. Infineon is going to present an extensive new range of solutions for the Internet of Things industry at the Embedded Solutions Conference 2021 near the Embedded World Digital event. So this is going to happen March 1st, and we're going to see devices covering sensing, computing, actuating, connecting, and securing. This is going to be all virtual. You're going to find a ton of inspiration and insights on embedded solutions in action. So register now at www.infineon.com/embeddedworld to discover how Infineon makes the IoT work. I actually will be signing up for this because it does look fun. All right, now let's talk about our hotline. Give us a call at 512-623-7424 and you will be entered to win the smart speaker of your choice. We choose a winner at the end of every month, so you've got until February 28th to give us a call, leave a message, and maybe we'll answer your question on the show. This week's question comes to us from Derek. Let's hear it.
Hi there. My name is Derek, and I live in Orange County, California. My question is about saving money on utility bills. I've always made like a little game with myself to see how much money I can save on each billing period, and I've kind of run out of things that I can save energy on. So I was wondering if there were any smart gadgets that I can use to save money, but I don't want to like spend thousands of dollars on them. I already have an Nest Thermostat E, so thanks for your response.
Derek, that is a great question. We've seen a lot of solutions for saving energy in the past. I'll be honest with you. To save money, you probably do have to spend money in many cases. But some easy, low-cost, high ROI type investments would certainly be replace any incandescent bulbs with LEDs. Over the lifetime of the LED, you're going to make your money back and then some. If you've done that, well, then we start getting into other things like your HVAC system, which you've already taken care of with your smart thermostat. But if you want to get a better outlook on what devices are using the most energy in your home, we have talked in the past about Sense, which is a product you attach to your electrical panel, and it basically uses algorithms to determine what devices are running, what appliances are running, and how much energy they're using. But Stacy, you had like a limited experience there. Yeah.
I've played with, there are other companies other than Sense. Schneider Electric has their Square D platform and Wiser Energy, I believe it is. These are devices you stick in your breaker box and they measure the electricity use in your home. The downside is I found that most of the electricity I was actually using well, and there weren't a lot of things I could change. You will probably, given the fact that this is a hobby for you, find that as well.
Plus it's a $300 investment.
And you have to have an electrician install it. So if you're just starting out, it might be a good opportunity, like a good thing to do. But my recommendation is actually to look at the energy guzzling appliances in your home. The number one is HVAC for most people. You've taken care of that with a smart thermostat. With the pandemic, it's going to be hard to get a lot of savings just because you're home all the time, right? So your options are to turn down the heat or turn up the air conditioning, as it were, to save money. Some other things, and we talked about LEDs. The second largest consumer of electricity in most people's homes is their hot water heater. And I feel like I'm on this huge Quanta rush lately because I've talked about it the last forever shows. But this is actually a device that not only tells you what your hot water heater is set at, but you can actually set it for lower temperatures. And over time, you can train it to optimize for energy reduction. So it will not keep your water hot, or as hot rather, when there's no need. So that's going to save some energy.
And there's a benefit to it as well. You can install this yourself. It's just a couple of wires. It's not too bad.
Yeah. and it's $149. The final device that might make sense for you that I actually saw some energy savings with, one of the other big consumers of energy in your home is your dryer. And the Smart Dry sensors, this is a $49.99 device that you just use a magnet and you pop it into your dryer and then you plug in a bridge nearby and it will track when your clothes are actually dry. So if your dryer is maybe older or its sensors aren't as adept, if your clothes are dry after 20 minutes, you don't have to run the dryer for 40 minutes or the full cycle. It'll just let you know.
The other aspect that happens in our house, so that the clothes don't get wrinkled, the dryer will turn off for a couple minutes when the clothes are dry and then run for another minute or two and then 5 minutes cycle off and it'll run. And we don't hear the buzzer, so we don't know that it's doing that. And it's just wasting electricity. This could send notifications to your phone.
Yeah, I'm going to send you one of these. I didn't know. My dryer does not do that. Wow. That seems like a horrible waste of electricity. And then finally, for vampire power devices, which, they can consume like 3% of the energy in your home, you can get smart plugs that turn everything actually off. That does mean that when you turn them back on, things are going to be a little slower on the uptick to start up. But those are some of the options we have available for you. And hopefully, maybe some of them will work. Okay. Thank you, Derek. That concludes that portion of the show. Remember, if you have a question for us or want to be entered to win a smart speaker, give us a call at 512-623-7424. And stay tuned for our guest this week, who is Alistair Allen. He is going to talk to us about building the Raspberry Pi Pico chip, why the Pi Foundation went with a custom designed chip, what it's optimized for, and we're going to talk a little bit about TinyML. All this and more await you. But first, a message from our sponsor. This week's sponsor is Very. Hey everyone, we are taking a quick break from the Internet of Things podcast for a message from our sponsor. This week's sponsor is Very, which is a full-service IoT engineering firm. And today I'm here with Dan Lindemann. Dan is a senior software engineer at Very, and he's going to talk to us about a recent project he worked on where he helped build a solar microgrid controller for a Very client that is doing some really cool things. Dan, can you tell us a little bit more about that project?
Sure. Essentially, the client we were working with wants to help 3.5 billion people who live in hard-to-reach places with underserved energy access. They wanted to get them reliable energy access. To do that, they sell grid management solutions to microgrid and distribution utilities in remote places and in developing markets in 25 different countries. So what they wanted us to do was to create a way for utility workers to use their product to see the usage status of meters and grids, to perform basic admin tasks and service account balances for their customers. So in just 7.5 months, we were able to deliver them fully validated pre-production hardware and robust firmware systems with another backend service and software app tying it all together.
That is a lot. Can you tell me a little bit more about how you did it and what challenges you and your team faced?
So IoT projects are challenging. In this case, we face some bonus challenges like when will the internet be in town? How do I create clean architecture when the hardware is shifting under my feet? And how do I quickly pivot to a different peripheral? So we did a few different things to make this successful. First, we used Elixir, Nerves, and Nerves Hub to develop and manage our firmware. We like these tools for firmware because they're secure, open source, and fault tolerant. They keep our software tidy by decoupling the firmware from the hardware. Second, we really focused on data minimization, which was really essential for this project because the microgrids being in remote locations means they don't have reliable internet access. It seems like it might be a really hard problem to solve, that you might have to do some very archaic things to get it right. But we found that we could actually use a lot of plain old Linux utilities. And this helped us to provide full utility data when low bandwidth internet might not be in town until next month. Finally, we built our custom hardware for this project. We start with commodity hardware like BeagleBones or Raspberry Pis, and those are great for prototyping, but they're too expensive for mass production. This is a place where Nerves came in handy because we could easily port Nerves into our custom build.
Awesome. So what was the end result?
We built a hub that collects energy utilization data from solar panel meters, allowing the grid operators the ability to efficiently process energy use and production on their grid. It's in the final certification and support phases right now, and we're excited to launch.
Great. Thanks so much for sharing, Dan. And where can people go to learn more about Very and the other projects you're working on?
You can learn more at verypossible.com/Stacy. That's VERY possible.com/STACEY.
Hey everyone, everyone. Welcome back to the Internet of Things podcast. This is your host, Stacey Higginbotham, and today's guest is Alistair Allen, who is the head of technical documentation at Raspberry Pi Trading, which is part of the Raspberry Pi Foundation, I believe. And Alistair's here to talk to us about the latest and greatest in Raspberry Pi-dom, aka the Pico. So, hello, Alistair. How are you doing today?
Hey, Stacey. I'm doing great. Thanks.
I am really excited to have you here because we're going to talk about my favorite things, chips and small chips and tiny ML, I think.
Oh, yeah.
Alistair is very low-key, very British. I love it. So first off, because you've been on the show before, you have a long history of research, science, and IoT stuff. How did you get involved with the Raspberry Pi Foundation?
So Eben Upton, who's the CEO of Raspberry Pi, and I have known each other for years. I know a bunch of the folks at Pi, and they, of course, have been working on Pico, Raspberry Pi Pico, and the RP2040, which is the chip at the heart of Raspberry Pi Pico for years. That you don't roll a new piece of ASIC overnight, right? That's not something you can do. And we were getting close to the release date, about a year away, and well, Eben realized there really wasn't any documentation and they should do something about that. So I had a phone call, and a couple of weeks later, I was sitting in the offices, because you could still do that back then. You could sit in an office at a table with people. And I was sitting in the offices, and Eben was writing on a whiteboard and describing this new piece of silicon that they were building there in the office, 30 feet away from me. I was just like, sure, I want to be part of that. Please let me be part of that. And about 4 days later, I worked for Raspberry Pi. So, it was one of those conversations.
Excellent. All right. So the Pico is exciting for our audience, mostly because it is, well, small. It is very small, and it's also relatively inexpensive. It's something that you could prototype for. We talked about, bringing intelligence to sensors. And it's notable for people like myself because it's the first time that the Pi Foundation has done its own silicon. Prior to this, the chips on most of the Pi boards are Broadcom chips, which is exciting, lovely. This is a little bit different. So can you talk to me a bit about why develop this product?
So Raspberry Pi Pico is a microcontroller, and the Raspberry Pi, well, I call them the mainline boards. The Raspberry Pi 4, the compute module, are microcomputers. They're SBC, small single board computers. And that's a very different type of product. A microcontroller there's no operating system. It's intended for a single purpose. And usually embedded deep into the heart of something. There's always been questions like, will Raspberry Pi ever do a microcontroller? And the answer really was, well, what can we as a company, we as a foundation add to that? There's Arduino, there's Particle, there's a whole bunch of boards from Adafruit, there's a whole bunch of different microcontroller boards out there, especially in the hobbyist market. And what would we add? And the answer to that is, well, we're going to go off and design our own silicon and do something that we feel is slightly different. The difference in Pico is not just that it's cheap. It's so the board itself is $4. The difference is the chip. So the RP2040 has been developed, how did Eben put it? Off leading diagonal, right? So it's a dual core symmetric Cortex M0 Plus. That in itself is really very odd. You don't get dual core Cortex M0 Pluses. That's not something that people do, because that would be mad. If you're going to put two cores together, you want to do something else.
So I'm going to interrupt you just for a second. For everyone who doesn't know, the M class is ARM's microcontroller class. The 0 is the itsy-teensy tiniest itsy-bitsy one of them. There's 1s and 2s and 4s, but this, in shoving two really, from my perspective, underpowered processors together is just a weird design choice. It's like harnessing two ants to a chariot. Go on.
Yeah, it is a weird choice, but there are a lot of other weird choices about this chip. There is 264 kilobytes, I think I've got that right, of SRAM, and there's no internal flash. All the flash is external. On Pico itself, there's 2 megabytes of flash, and that's going to be the smallest amount of flash you'll ever see. Most of the third-party resellers that are picking up the RP2040, Adafruit, Pimeroni, SparkFun are putting 8 megabyte flash chips on, and I've seen 16 megabytes, which is the most you can put on the chip. It's designed to be to have a lot of memory. It's designed to have dual cores running very fast. These 133 megahertz clocked cores.
What were y'all trying to optimize for? Because every time you design a chip, you have goals.
So this is not a low-powered chip. There are lots of other lower power chips out there. That's not what we were optimizing for. We're optimizing for cost. We're optimizing for usability.
What are the jobs that you guys think, and obviously people will come up with their own, but what jobs do you think this is designed for?
So this chip has been designed above anything for flexibility. So it's a hard question to answer. One of the things that you'll see in a lot of other microcontrollers is that specific peripherals like I2C or SPI are pinned to certain GPIO pins. So you can only use certain pins for certain things. If you look at the pinout on the RP2040, you can pretty much use any pin for any purpose. But it's designed for flexibility. It's designed for direct memory access. It's designed for throughput. It's designed to move data very quickly from the pins through the processor and back out the pins again. So you've probably seen quite a lot of the video demos online over the last few weeks. So if you slightly overclock the processor, you can do HDMI with this chip, which is insane. There's a video demo from one of the Raspberry Pi engineers of a dual monitor HDMI. Well, okay, it's DVI over HDMI, but it's insane to come out of an Cortex M0 Plus. That's absolutely insane. And it's because of the architecture of the chip. So flexibility, I think, is the answer to your question. It's designed and optimized to be flexible.
Okay, so then the next obvious question is, why is Raspberry Pi getting into the microcontroller game?
There are obviously multiple layers to this, right? And you can talk about a commercial layer, you can talk about the overall goal of the Raspberry Pi. So if you want to talk at the foundation level, the overarching level, is obviously always the answer is going to be education. The way I put it is that the Raspberry Pi was a computer that taught you to program. From my point of view, the way I came into this, the RP2040 and the Raspberry Pi Pico is a board and a piece of silicon that can teach you how to build a product. And that was the goal that I went in just over a year ago now, to build the documentation, how the documentation looks around it. And so a lot of people coming to this chip and coming to this board from more traditional microcontroller backgrounds have been really surprised about the way the documentation has been structured, about how the SDK has been structured. And to a certain extent, the answer to that question, the confusing bit for those people, is education.
Got it. And so how does this compare to something like an Arduino, which is what that's the slot Arduino has historically filled?
It depends what you mean by an Arduino, right? If you're talking about something like an Arduino Uno which has an AVR processor, this is an ARM processor. Even a Cortex M0, like in a performance-wise, will take an AVR processor and beat it around the head with a big stick. It's not the same class of device. But then if you look at other Arduinos, more modern Arduinos, obviously some of those already have ARM processors. The Pico was designed to be low cost as a board. So this is a $4 board. It doesn't have a lot of the features you'll find in, for instance, the Arduino MKR boards or Adafruit's Feather boards. It doesn't have LiPo support. It doesn't have inbuilt RGB LEDs. It doesn't have accelerometers or gyroscopes or magnetometers. Right, it doesn't have those. But I mean, if you want that, with an RP2040 on it, you can have it. It's like Arduino is going to put out, and I can't remember what they're calling it, RP2040 IoT Connect or something like that. And of course, the people that have been wondering where Arduino support was for the RP2040 and the Raspberry Pi Pico, well, it's coming because Arduino's building a board and it'll support our board just as well.
So yes, you mentioned the TensorFlow port. There are so many options out there right now for doing tiny ML. TensorFlow Lite is actually pretty top heavy, and there are tons of custom silicon options out there. It's probably exhausting for anyone trying to evaluate microprocessor for doing tiny ML. So because you're so smart at this, can you talk to me about how you're thinking about doing projects on the Pico and what kind of optimizations it might need and how far away we are from using the Pico for those kinds of projects?
So one of the things that it made me end up in the job that I'm in is that I spent about 6 or 9 months benchmarking the acceleration silicon. So Google Coral, NVIDIA Jetson Nano, Intel Movidius, and a couple of other things, along with the Raspberry Pi. So I spent quite a long time doing TensorFlow on the acceleration platforms. And so, yeah, I'm fairly familiarized with the sort of performance capabilities of acceleration. And that is a very different level of inference, of power draw, of modeling than the TinyML stuff. So a lot of people are looking at Raspberry Pi and going, that's TinyML. And personally, I wouldn't say that. That's a full-blown computer. That's a desktop machine. TinyML is going down to the Cortex-M level. It's going down to Cortex-M3, Cortex-M, even a Cortex, and a Cortex-M0 Plus. So it's really low power in the milliamps, not in hundreds of milliamps, which you're getting for something like a Raspberry Pi. So TinyML, from my point of view, is the Cortex-M level. The RP2040 is not a low power chip. We've talked about that. It's not what we optimized for, but it does get a huge amount of throughput. So I don't know, you might have seen the very first, as far as I can make out, not us example of machine learning on Pico, which was the ArduCam folks. ArduCam have taken the ArduCam and connected it up to Raspberry Pi Pico and done machine learning with TensorFlow Lite for microcontrollers. So they're doing real-time machine learning. I think they're getting about 2 frames a second, something like that, off the camera, doing person recognition, so figure recognition.
That makes sense. Okay. And I still think there's a lot of confusion about the opportunities for TinyML. And this doesn't have to be what you plan to build on your own Picos, but I always ask people, because the world is wide and people have all sorts of crazy ideas. When we're talking about doing inference at the farthest edge, so the tiniest ML, what are the use cases? What are the things that you think we should be thinking about? I'm sick of wake word detection. Let's go beyond that.
Yeah, I'm really sick of wake word detection. Wake word detection is not a great case, right? The thing I think about when I think about TinyML is no internet at all. The future of the Internet of Things might have a lot less internet than you previously might have expected.
I'm very hopeful.
So from my own point of view, the point of TinyML is distributed intelligence, right? Is to distribute the intelligence out into the world. It's to have reactive things, to have reactive sensors. So take sensor data, process it right there on the board, and then have an actuator that does something. Is to have an interactive world around you, not necessarily one that has to go out and talk to the cloud and do heavy duty processing. It doesn't have to be like a heavily sophisticated thing, right? It's emerging complexity. If you have lots of little things that do little things on the edge, then all of the little things contribute to big things. If your environment is reactive, then you don't need the cloud.
That is true, unless you're pulling down data that you need to add for extra context. But there are plenty of areas where, like my lamp, I don't actually think my lamp needs that much context.
Right. There's no reason why, if you're turning your lights on and off, you have to go to the internet, right? That makes no sense. I mean, this is something I've been talking about for years, right? I did a startup on this back in the stone age of the Internet of Things that went bust, as like most Internet of Things startups went. But, it's like, if you're turning your thermostat on and off, why does the thermostat have to talk to the internet, right? It's like, it has temperature sensors in your house. Why does it leave your local area network? It shouldn't have to. And especially for lights. Back when the GDPR came in, this is getting really off topic, but like when the GDPR came in, I can't remember whose lights locked down the app, right? Their iPhone app basically came up with a big pop-up and said, hey, you give us permission to process lots of personal data and store it in the cloud. And if you click no, they turned your lights went dumb. So from my point of view, TinyML means that you can do smart things right at the edge, that you can do smart things from the devices that need to be smart. instead of embedding the smarts in a data center in, wherever they're building data centers these days, next to waterfalls, right?
Well, before we go, I have to ask, because we have a bunch of Pi lovers in the audience, what's next after the Pico?
Okay, so at Raspberry Pi, we have a policy of not talking about future products. That's just a flat-out thing. We don't talk about future products. And as a result, everyone is very surprised when we release products. It's great fun. But you don't build an ASIC group to build a single chip. I think that's very obvious to anyone. So yeah, sure, there's probably more silicon coming from Raspberry Pi. And what that's going to be like, well, we're going to have to think about that, right? That's a decision still to be made. We're really still very, very close on the heels of RP2040. We're seeing how people are going to use it. We're seeing how people are going to use it that really surprises us, because I'm sure they're going to be surprises. I think that the great adage is that no plan survives contact with the customer, right?
Something about that, except I thought it was war in the enemy, but sure. I prefer from the Raspberry Pi Foundation a more customer-centric friendly adage. All right. Alistair, thank you so much for coming on the show this week.
Thank you so much for having me.
That's it for this week. Thanks so much for listening. And remember, if you'd like more IoT news, sign up for my newsletter at stacyoniot.com. We'll see you next week.